Okay, welcome to chapter 1, mechanics, vectors. Okay, this is chapter 1, vectors, not chapter 1, UARM. So this is the vectors, and the book for vectors can be found under term 1, week 1, in the material. It says physics vectors, and you can find the book. It's just a PDF of all the pages in case you want to read the book. But for vectors, I don't know. I don't think that's really necessary to read the book. Uh, Whatever you want. But I'm gonna go through this a bit quicker. I just submitted fast because I want to get this recording over with. It's vectors, it's very easy. Okay, so we're gonna go over it a bit quicker. Um, Consider the fun. Okay, before starting, by the way, if you're studying this for the periodic in term 1, week 5, the one on September 20, 1, 2, it's 21, 22, 23, September 23. Make sure to watch the live on Sunday, September 22 at 8 p.m. UAE time, because I'll be going over the stuff you need to do for written and be solving some questions that will also come in the computer part. Anyway, consider the following two position vectors. You have A, which is magnitude 12, and its angle is east 60 degrees south. That's a bearing, right? North, south, east, west. East 60 degrees south. So you go east, then you go south 60 degrees. So east, then you go 60 degrees south. So it's going to be like this. Okay, this is a bearing, right? This is a bearing when we're working with east, north, south, whatever. That's a bearing. So we have this for now. And then we have B, which is a magnitude of 20, and its bearing is 300. Okay, so its bearing is this is 90. Remember, the bearing starts at north. Bearing. Remember, bearings, they start at north and they go clockwise. So they go like this. Okay, but the normal angles that we use for vectors, they start at the x-axis and they go up counterclockwise. Okay, this is how bearings are. Okay, just a quick reminder. Okay, this east 60 degrees south, it's a way of saying bearings, but this way they call it mariner's compass in case they ask it. Yani. Okay, in case they say put your answer in terms of the mariner's compass. Okay, you just put it like this. Anyway, yeah, at a bearing of 300 degrees. So this north south, this one B, its bearing is 300, so it starts at north and we go 300. So 90, 180, 270, and 300. Okay, so this is 300, yani هيدي 30, because this is 270 and then this is 30. Okay, because 90, 180, 270, and then this 30, 300. Okay, I and J are unit vectors, la 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 la. Okay, they want to add vector A and vector B. Okay, أول شيء we need to express vector A in terms of Cartesian coordinates. You know, Cartesian is I and J. نحن first, to express it in Cartesian coordinates, we need the magnitude R, and we need the angle theta, right? It's in polar coordinates. Here we don't have angles, but we have bearings, right? The bearing here, it starts at north and then it goes 60 degrees, 90 plus 60. This is 150 degrees. Its bearing is 150, and the bearing here is 300 degrees. So over here, what's the angle gonna be? Remember, I told you to convert from a bearing to a normal angle. You do 450 minus the bearing. So in this case, 450 minus 150 gets you 300. Okay, so we're done. Like we changed the we changed the mariner's compass into a bearing, okay, 150, and then we change that bearing into the normal angle that we use, theta. Over here, our bearing is 300, so we do the same thing to change it into a normal angle. 450 minus 300 equals 150. And if you do this in your written part, it's completely correct, by the way, to do 450 minus bearing, okay? Anyway, so you get 300, you get 150. And we have the magnitudes, so this one is 12 and the angle is 300. Okay, and this one here is 20 and the angle is 150. Okay, can we now find the x component I and the y component j? Yes, see. Let's see. X of A, it's equal to the force cosine theta, right? Which in this case is equal to, see, 12 cosine 300. 6. Okay, we want to add it to the other vector, so we don't like waste time. Okay, here we get 6, and here the x component is 20 cosine 150, right? So 20, so plus 20 cosine 150. Why are we adding? Because they said a plus b, huh? And you get 6 minus 10 radical 3. So your I component, I and your x component, 6 minus 10 radical 3. But then the y component, you know, it's force sine theta. right? And here come in, it's the y component is b. The y of b is equal to the force sine theta. Okay, so we're gonna add these to each other. 12 sine 300 plus 20 sine 150. Okay, 10 minus 6 radical 3. Okay, go through this a bit quicker. That was too slow. Okay, we have these vectors. We want a vector equal to a. Remember, if a vector is equal to a, that means it has the same magnitude and the same direction. Okay, let's see. A is kind of like two squares diagonally, so the vector equal to it has to be also two squares diagonally, and since A is pointing upwards, it should also be pointing upwards, so A and H are equal. Vector opposite to H. If it's opposite to H, that means it has the same magnitude but opposite direction. So it should also be two squares diagonal and like going the opposite direction. Akid is going to be B because it's going down. Vector parallel to D. If a vector is parallel, that means it's going in the same direction, regardless of its magnitude. It doesn't matter about the magnitude, it's only the direction we care about. So parallel to D, which one is going in the same direction as D? D is going up, straight up. The only other one is F. Okay? Vector that is a scalar multiple of D. If it's a scalar multiple of D, that means also it's going in like, okay. When you multiply a vector by something, you extend its length, right? Or you extend its magnitude. If you multiply the vector by a negative number, you would extend it, but in the opposite way. So let's just see if something's going, if D, and if you have something going in the opposite direction of it or in the same direction of it. Okay, D, there's nothing going down, like opposite down. There's nothing. Okay, we only have F because it's a bit bigger than D and it's going up also. Okay, that means it's a scalar multiple. Unit vector, yani it's just one. Okay, 1. Okay, and there's no other one than D. Don't say E because this is not one unit. It's a square. Okay, going diagonal. This is, if it was 1, 1, this would be 1 radical 2. Okay, because it's the hypotenuse. If you do Pythagoras theorem, you get 1 squared plus 1 squared equals hypotenuse squared, and you get a radical 2 as your hypotenuse. Okay, so that's not 1. It's not 1. I'm just proving it to you. Okay, the sum of two vectors A and something gets 0. Akid, a vector plus something to get 0, that means you're adding its opposite, right? And B is opposite to A. We saw here. B is opposite to A. It's opposite to H, but H is equal to A, so like, same thing. Okay. The diagram below shows OA and OB. Vector V is OA plus OB. What is V? Okay. They're saying each small square is 1 meter. Okay. Our sheet, let's see what is OA, what's OB. OA, please, if you have written vectors, you need to put vector symbol. You need to. You have to. If you don't, you get it wrong. I'm telling you, you'll lose marks. 0.25 marks for no vector symbol. Okay. Here, what's OA? It's 2 to the left, so minus 2i plus 1 up, so 1j. How about OB? OB is equal to 1, 2, 3. I should change my color to red. 1, 2, 3 to the right, so 3i. And then 1, 2, 3 up, so 3j. Okay. We want OA plus OB, so we just add these. Minus 2 plus 3, that's 1i. And then 1 plus 3 is just 4j. I don't know why I bugged there. Okay, if the head of vector V, so vector V is 1i plus 4j. Okay. Come on, put the vector symbol on. Here they don't put the vector symbol, but they put it in bold. Okay, on computer, because you can't like type the vector symbol, they put a letter in bold, meaning that it has a vector symbol above it. Okay, even in the IG physics, IG mechanics, as the AS mechanics, and IG math, for those of you who might do it this year, you'll see this in your IGs. If the head of vector V is placed at a point with coordinates minus 3, 1, the tail of such vector will have what? Okay, head. Okay, we know the vector is composed of a tail and the head. Okay, this is the tail, this is the head. Okay, so in other words, we can say that the head is the final point. Okay, and the tail is the initial point, right? Initial point. We know that a vector, the vector, any vector is equal to final, like x final minus x initial, and then it's y, the y vector would be y final minus y initial. Remember, like if you have a vector going from, like here, مثلا, see here, like see here, for like OA, its y final is 1, and its y initial is 0, and its y final is, its x final is minus 2, and its x initial is 0, so minus 2 minus 0, and we got 1 minus 2. Isn't that the same thing as what we got here? 1, sorry, it should have been minus 2. Upside down, and x comes first. But you get what I'm trying to say, right? So here, we know that the vector, when you do final minus initial, you get the vector. And what is the vector v? It's 1 and 4. 1 and 4. They said that the head, so the final, is minus 3, 1. So they gave us x final and they gave us y final as minus 3 and 1. So minus 3 minus x initial equals 1, and 1 minus y initial equals minus 3. And you're going to get here minus 3, it should be minus 4. Yeah, you're going to get x initial is minus 4. If you take minus 3 to the other side, yeah, you get minus 4. And you get y initial is f minus 3. Am I bugging? 1 final minus initial. Do I not know how to solve math? Minus 4. يا ربي. يا أخي, I switched them. Why did I switch them? Did I switch them? Am I tweaking? يا ربي. You get 1 here. Okay, final x minus initial x. We're trying to find it, the tail. Okay, final is minus 3 and the vector is 1. So minus 3 minus 4. Yeah, okay. X initial is 4 as the minus 4. Okay, makes sense. Then final y 1 minus initial y, we don't know, get you the vector 4. Why did I put minus 3, Anna? Why did I put minus 3? The vector is 4. Ya Allah. Yeah, 4. Okay, then you get y is minus 3. That's how you do it, okay? Vectors, final minus initial, okay? Question 4. Given A is minus 3, blah, 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 B is this, AC is this, V is this. Okay, coordinates of V. V is 3AC. We have AC, which is 3I plus 4J. Okay. And then minus 2 times BA. We don't know what BA is, but we can find BA. We know that BA, the vector BA, is equal to the final point, which is A, so x of A, minus the initial point, x of B, and then the y of the final point, which is A, minus the y of the initial point, B. So in this case, it's going to be x of A, which is minus 3, minus x of B, which is minus 5, and then y of A, which is 4, and then y of B, it's 0. You're going to get minus 8, 4. So minus 2, and then this is going to be minus 8i plus 4j. Please, again, pay attention to the vector symbol. If you don't put vector symbol in your written, you're going to get it wrong. I'm telling you from now. Okay, don't be surprised. 3 times 3i is 9i. 3 times 4j is 12j. Okay? Minus 2 times minus 8i is plus 16i. Minus 2 times 4j is minus 8j. Okay? 9i plus 16i is 25i. 12j minus 8j is 4j. Okay. If the tail of V, same question. If the tail of V, any initial point, okay, V, okay, x initial and y initial. They gave us the tail, right? So they gave us minus 1 and 2. Where is its head? So where is the final point? We know that the vector is equal to final minus initial and y final minus y initial, right? Okay, we know that the vector is equal to 25i and 4j, so 25 and 4, right? Okay, what is the final point, which is the head, right? So now we're trying to find the x final, y initial, y final. That's what we're trying to find, the head, which is final, and y, x final, y final. So x final minus x initial, which is minus 1, equals 25, and the y final minus y initial, 2, equals 6. Choose 6 as the 4, the vector, right? Okay, x final minus 1, you get 24, because xf is 24, and then y final you get is 6. Okay, easy as. So easy, wallah. Question 5, try and get this recorded. Okay, there's two forces acting on a particle given by F1 and F2. What are the components of the resultant force F? Resultant force, yani add them up, right? So I plus 2i is 3i, minus 2j plus 6j is 4j. Okay, again, if يعني أنا honestly I don't think, did my headset unplug? No, it's still there. Okay, أنا honestly I don't think he's gonna get the vectors in written. Maybe he does. Okay, maybe if he does, please put the vector symbol and put the unit if there is a unit. Like, see, if the question they put Newton, يعني انت in your answer you have to put Newton. Okay, please don't forget, these are all things that could lose you marks, and it's a very, very common mistake, يعني, and I won't blame you, but I'm telling you countlessly and repeatedly, I'm telling you, put the unit, put the symbol. If they put the vector symbol, if you don't put the arrows or units and after all this, then it's your fault. What is the magnitude of the resultant f? How do you find magnitude? We know it's radical x squared plus y squared, or don't write it like this, huh? X of f plus y of f squared, and you get 5. Okay, if this comes written, what's the angle between the unit vector? We know that the angle theta, okay, equals shift tan y over x. So in this case, it's gonna be 4 over 3, yeah, shift tan 4 over 3, which is 53.13, I think, but they want just 53 degrees. Okay, for now it's just shift tan. I think in the next question they ask about the rule. Okay, no, later. Okay, the velocity v is 9i plus 3j. What's the unit vector? How do you find the unit vector? The unit vector u, okay, is equal to vector v divided by the magnitude of vector v. Walid, what? Okay, let's see. What's the magnitude of vector v? It's going to be radical 9 squared plus 3 squared, which is 81 plus 9. No, radical 90. Okay, which is, let's just keep it as radical 90. Radical 90. Okay, 3 radical 10. Okay, so this is the magnitude, right? How do you find the unit vector? You divide each component by the magnitude. So we have 9i, so it's 9i, 9 over 3 radical 10i, and then plus 3j, so 3 over 3 radical 10j. Okay, they want it in decimals, so let's see, 9 divided by 3 radical 10, so 9 divided by answer. I should move this here. You get in decimal 0.95. Okay, then 3 divided by 3 radical 10, 3 over 3 root 10, 0.32. Okay, the angle of elevation again of the bullet, right? Of the bullet, not the unit vector, okay? Of the bullet is shift tan y over x, 3 over 9. And you get 18 degrees, I think. Shift tan 3 over 9, 18.4, whatever. Question 7. Okay, yeah, this is the rule. Okay, we know that theta equals shift tan y over x if x is positive. Again, to help you understand, if x is positive, maneta, we're going like, it's like this, you know, this here. Okay, the angle here, it's like a triangle, you know, shift tan y over x. If x is negative, that means we're over here, right? Where's x negative? On the left, right? If x is negative, then akid you have to add some angles. So you have to add 180 if x is negative. Okay? Because in case they give you x is like, they give you the vectors negative 3i plus 4j, remember you should add 180. Okay. If, sorry, when is theta equal to 90 degrees? When is it equal to just 90? When the vector is over here, right? What is here when x is equal to 0, right? Okay, and y is positive. If x was equal to 0, but y is negative, then we would be over here. And what would this angle be? 90, 180, 270, right? Okay, so 270. Okay, then here they gave us if x equals 28 and y is minus 45, then the polar coordinates of v. Okay, polar. Okay, you can just do this on a calculator, by the way, okay? But if in an exam you get it, to convert from Cartesian to polar, actually you find the magnitude and then you find the angle. How do you find the magnitude? Okay, and you can just do shift pole and then put 28 minus 45, okay? Let's see, 28 minus 45, what do you get? 53 and negative 58. Yeah, but in this case you have to do, what's the other answer? It should be positive. Yeah, 302. Okay, 28, we have to find the magnitude. So radical 28 squared plus minus 45 squared. So you could just say 45 squared. Okay, but in a written, don't put 45. Put plus and then negative 45 in brackets and then square outside. Okay, and if you get written, you put it like this. Okay, like this. You get 53 is the magnitude, and then we said shift tan. If x is positive, we just do normally y over x, right? So negative 45 divided by 28 minus 58. Question 8. Okay. Okay, u is this, magnitude of v is this, okay, and they give us theta is this. What is the polar coordinates of u? Okay, we know the polar coordinates is r cosine r and theta, right? So first we need the magnitude, and they said magnitude of u. This symbol isn't absolute value in mechanics, it's actually magnitude, okay? And then theta is the angle. How do we find this? U, the magnitude of it, how do we do it? We do radical minus 9 squared plus 40 squared. Okay, and you get radical 9 squared plus 40. I'm not putting the minus 9 because I'm trying to save time. Okay, you get the same answer. You get 41. Okay, at an angle of, let's see, we want the angle. So it's going to be shift tan y over x. But let's see, isn't our x negative? Yes. And what do we do if we add, if it's negative? And you add 180. Okay, so shift tan. Okay, 40 over minus 9. Okay, and then okay, we add 180. Okay, you get 102.6. They want to the nearest. Yeah, we could put 1 point. Okay, whatever. They tell you any in the exam. Okay, how many significant figures? The Cartesian coordinates of v. Okay, we want to convert now v. It's polar. Okay, we want to convert it to Cartesian. If it's in the computer part, please don't waste your time. Just press shift recall. Okay, 37, negative 71. Bam, you get 12 and negative 34, negative 34.9. Yeah, it's negative 35. Okay, if you just don't waste your time. Okay, if you do, you have to do magnitude times cosine theta for the x coordinate, for the x component, and the magnitude times sine theta for the y component. Okay, so 37, like I'll do the x component fast. 37 cosine negative 71, you get 12. Okay, and if you do 37 sine negative 71, you get 35. Okay, question 9. طول على recording. In polar coordinates, position vector r is given by r is 73 and theta is 49. A position vector opposite to r is given by, okay, let's see. We want opposite to r. So أول شيء we want to find we want to find the Cartesian coordinates of r and then make it negative, right? A lot of people asked me this in the last, or when we had this in the physics CA, they were like, Walid, whoa, why is the answer negative? ما حبيبي مكتوب opposite, okay? Let's see. Let's change this into Cartesian coordinates, okay? How do we change it if it's on computer, huh? If it's written, do magnitude times cosine for the x component and then magnitude times sine for the y component. And I'm not gonna waste my time because صراحة ما لي خلق على حالي. Okay, 49. You get this. Okay, so you get 48. Okay, I plus it should be 55. Yeah, 55g. Okay, they want opposite. Okay, so what does become negative 48, negative 55? Okay, ما بدها هالقد وحياة الله. Okay, and then they say a position vector perpendicular to r. Okay, perpendicular to r and located above the x-axis. If you want something perpendicular, you just add 90. Okay, I'm telling you. Okay, 49 plus 90, 139. But if they said below, if they said instead of above, below, then you do what? Minus 90. So it depends. You either add or minus 90. You don't add anything else because you said perpendicular. Okay, the angle OA makes with the positive x-axis to blah, 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 blah. Okay, here we can find, you should be able to find the vector OA. Okay, they should tell you that each square is 1 meter, but if they didn't, that means that's what they're trying to tell you, because otherwise there's nothing else you can really do in this question. 1, 2, 3, 4, so minus 4i, that's j, sorry, minus 4i plus 1, 2, 3, so negative 3j. Okay, ماشي. How do we find the angle here? Let's see, it's gonna be shift tan y over x, right? But here x is negative, so what do? We add 180. ماشي. So shift tan 3 over negative 3 over negative 4, negative 3 over negative 4 plus 180. You get 216. Okay, to the nearest degree, 217. Okay. What's the bearing of OA? What's the bearing of OA? If you want the bearing, you can just do 450 minus 233. Okay? To convert from bearing to degree, 450 minus. To convert from degree to bearing, 450 minus. Okay? It works both ways. Two possible ways to describe OA using Mariner's compass. Okay? 233 degrees. Let's see. Mariner's compass, yani we want to see north, south, east, west. The bearing is 233 degrees. Okay, so which quadrant are we going to be? Remember, with bearings and Mariner's compass, you start at north. Instead of going like this, that's for x components ما بعرف شو for vectors. But for Mariner's compass with bearings, we start at north, we go clockwise. So هيدي 90, هيدي 180. وهون, this is 233. So let's see. We can either go, we know that this is 180 over here. Okay, 233 minus 180, you get 53. Okay, so this angle over here, this is 180, and this angle over here is 53. ماشي. So we can either go south 53 degrees west, right? South and then go west 53 degrees. Or we can go from west. If this is 53, then this is going to be 37, right? Because 90 minus 50, you know, this is the right angle. So 90 minus 50, then this is 37. Or we can go west 37 degrees south. Okay? Both work. So west 37 degrees south and south 53 degrees west. Question 11. Okay, the angle OA makes with the positive x-axis. Okay, the angle with the positive x-axis. This is, and instead of bearing, the other thing we call it is with positive x-axis, because this is positive x-axis and height. Okay, so they want this angle. How do we find it? You can do it like this. We need to find the vector OA. OA, it makes an, they gave us, it makes an angle of 30. Oh, you don't even need to find the vector. They told you that it makes an angle of 30 with the y-axis. So with the y-axis, it's 30. هيدي أكيد it's 90. يعني how much is it? 120. 90 plus 30. What's the bearing? Okay, we do 450 minus 120, you get 330. In the Mariner's compass notation, how can you put 330 as bearing? Let's see. We know that the bearing starts at north and goes all the way like this. We know this is 330. Okay, this is 330. Okay, let's rewrite this. I want to see this small angle over here. Okay, we know that this is 90, 180, 270. يعني إذا هيدي 270 قد إيه هيدي؟ It's gonna be 60, right? Oh, and it was pretty obvious. They told us it's 30 here. أكيد if it's 30 here, and هيدي it's 60. How can we get the bearing here? We can either go west 60 degrees north, right? West 60 degrees north, or from the north we can go 30 degrees west, right? Both work. Question 12. Vector OA of length 17 meters has direction east 28 degrees north. Assume that the northern direction coincides with the positive y-axis, to the nearest meter. Okay, they want us to express it in Cartesian coordinates. أول شيء we need to convert it from polar into Cartesian. And we don't even have the angle first. So we need to convert the bearing into an actual angle. Do we have the bearing yet? No, we don't. How do we do it? I'm telling you. If you ever have this in your exam, draw. These Mariner compass, you can't solve it unless you can see it. East, north, south, west. If you don't know coordinates in grade 11, wallah, I don't know what to tell you. KG2s, grade 1s, they know this. Okay? East, 28 degrees north. So you go east and you go up 28 degrees. Okay. How much is this bearing? Let's see. We know that the bearing starts from north. So we want this. That's all we want. How do we find it? We know this is 90. So 90 minus 28 is 62. Okay, and the angle will be 450 minus the bearing. We found the bearing, 450 minus 62 equals 12, that's 388. I think. Is it? Wait. I think my calculations are wrong. 90 minus 28. Okay, 450 minus answer. 388. Okay. So the angle is 388. So we're gonna use Honestly, it's wrong to say 388, but let me see if it works. Let me see. 17 cosine 388. Okay, it works. If you have it in computer part, it works, and I guess it should yani, work also in the written. If you do, let me see, 388 minus 360. Okay, 17 cosine answer. Yeah. Listen, logically, you shouldn't get anything above 360. Although it would work, if you do, yeah, if you on computer it's completely fine, huh? But if you have it unwritten, I'm not sure هلا. But to stay on the safe side, if you get a value above 360, just subtract it by 360 and you use 28 degrees. Okay, if you get it in the written part. But here عادي ما لها طعمة. Okay, doesn't matter. كمان I told you guys I don't think he's gonna get vectors in the written. Okay, maybe he will. He's gonna get from the past papers that are in the material, which there's a separate video for that soon يعني. Okay, but for now 17 cosine 388 15 and then 17 sine 388 8. Okay, again you can just put it in the calculator. Shift recall 17 388, they'll give you 15 and 8. Okay, consider the vector OB which is perpendicular to OA. From the smallest to largest, the two possible bearings of vector OB are bearings, huh? Okay, let's see. Now, do we have the angle? We have the angle is 388. Okay, 388. Wait. Yeah, 388. For here, if you use 388, it will be wrong. You can't. You can't. Just use the angle 28, like I told you. Just to stay on the safe side, guys. خلاص. Let's not solve with angles above 360. If it's above 360, just subtract 360 to get the angle 28. Because by the way, guys, if you look at this, 28 degrees is over here. This is 28. Okay. If you take 388 degrees, this is 360, and then 360 plus 28 is the same angle. Okay, you get the same final position. So just use anything above 360, just subtract by 360. So we're going to use 28. How do we get it? We always said 28 plus 90, which gets me 118, or 28 minus 90, which gets me, should be negative 62. Okay. Hala. So here we got this. We want to convert it to a bearing. So you do 450 minus 118. Okay, this works. You get 332. Good. But this 152 is the problem. Because if you do 450 minus 62, like here, 450 minus 62, you get 512. What if you subtract 360? Okay, yeah. If you do 450 minus 62, this is above 360, right? If it's above 360, what did I tell you to do? Like up here, just subtract 360. 152. Okay, that's it. Question 13. Okay, a unit vector OA is given as this. So this is the unit vector U. Yeah. They said that the bearing of OA, okay, is 196 degrees. Consider vector OB anti-parallel to vector OA and its magnitude is 25 meters. Anti-parallel, okay, means same magnitude but opposite direction. Okay, ماشي. They said OB, its magnitude is 25, blah, 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 blah. OB can be expressed as 7. Oh, okay. They want you to find OB. Okay, wait. Did I skip part A? Okay, how she find the bearing? I'm so drunk. Wait. So to find the bearing, they're basically asking us first to find the bearing. We need the angle, right? And how do we find the angle when we have? How do we find the theta? We do shift tan y over x, so negative 0.96 over negative 0.28. Okay, and remember, since x is less than 0, what do we have to do? We have to add 180. طب نحن they're asking for the bearing, not the angle. So how we convert from x angle with x to bearing? We do 450 minus. You get 196. So we know that the bearing of it is 196. Consider vector OB. Okay, is my mic on? Yes, it is. Consider vector OB, which is anti-parallel to vector OA, and its magnitude is 25. Okay, OB can be expressed as what? Okay, so to help you understand part B, when we say anti-parallel, it's the same magnitude but it's an opposite direction, right? Opposite direction. If we draw this, okay, just so you can help understand it, we know that the bearing of OA is 196. So this is north, south, east, west. 196, so you go, here's 90, 180, 196 will be somewhere over here, right? Okay. If it's opposite, that means it's going in the opposite direction. So it's going to be like this, right? So in other words, we could say that OB is opposite to OA, right? So if we can just find the Cartesian coordinates I and j of OA, we can find OB by just finding the opposite, by making them negative. You get what I mean? So here we know that the unit vector, you guys know that the unit vector u, to find any unit vector, it's equal to the vector v divided by the magnitude, right? So in this case, they gave us what the unit vector is, negative 0.28. Okay, how do we find, what's the formula for it? It's the vector v. We don't know what we're trying, we don't know it, right? We're trying to find it. Let's call it OA, right? Over the magnitude of it, which is 25. Since they're anti-parallel, we said that they have the same magnitude. So OA, the I component, or the X component, is just going to be negative 0.28 times 25. Times 25. And you get negative 7. So the I component is negative 7, right? So OA is negative 7I. How about the J component? Let's see. The J is negative 0.96. Remember that the unit vector, it's given. The unit vector equals the vector V, the original vector, we don't know it. So again, the J component of it, divided by the magnitude, which is 25. So here, they just swapped it around, and they want you to just cross multiply. It's nothing hard. So OA is going to be negative 0.96 times 25. Negative 0.96 times 25. So 24, negative 24 J. So this is the vector OA. نحن we said it's شو anti-parallel. يعني it's the opposite direction. So these two we change them. What's the opposite of negative 7? 11. What's the opposite of negative 24? 24. ما بدها هالقد. Okay. If the northern direction coincides with the positive y-axis, okay, and the eastern direction coincides with positive, oh, la 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 la. The mariner's compass direction of OB is given by what? OB, right? OB is like this. We said that this one was OA, and أكيد OB will be opposite to it. So we said this is here 196. We want now to find the direction of OB, right? This is OB over here. The angle, okay? I can give you an easy trick, okay? Know that when you have two opposite vectors, like this, on a coordinate plane, the angle between them is always 180. Always. Because this is a linear pair. It's a straight line, you see? It's a straight line, so it makes 180. This is from geometry, basic geometry. So this is all 196, and this is all here 180. Can we find the small part here? Yes, we can. It's 196 minus 180, which is 16. So anytime you have two opposite vectors, you can just subtract by 180, and you get 16. So this angle here is 16, and in the mariner's compass, from the north, we're going 16 degrees east. If they said north, something east. So you can't, since there's no, they didn't give you the option to put east 74 degrees north. If they put east, then north, and you put 74. But here they're saying north, then east. So north 16 degrees east. Question 14. A vector is as follows, okay? Its magnitude is 16.5, and they give us the mariner's compass is this. Okay, in polar coordinates, what is the direction? Direction in polar coordinates also يعني theta. Okay, let's find the angle. Okay, let's see here. West 53 degrees north. This is west, and this is north. 53 degrees north. So here it's 53. Okay, how much is this as a bearing? Let's see. This is 90, 180, 270, and then plus 53. So 270 plus 53, it's 323. Okay, this is the bearing. We want the direction, in polar terms. How do we find that? To convert from bearing, 450 minus 323. You're gonna get 127. Yes, 127. Okay. Oh, and part B, they said, what is the bearing? Okay, yeah, you can do that. Just 323. The way they did it is differently. Okay. Yeah, if they're finding. Okay, listen. In your exam, uh, our head of physics, he mentioned this to us. You might get like, well, this is later for the next quiz with UARM or whatever. Like, I'm gonna give you the example because this is how you, or let's give you this example. Let's say you got this in written. You can't say that the bearing is 323, okay, and then like say, I'm not sure about this. Like you can't answer part B before answering part A. Do you get what I'm trying to say? So like here in part A, how they solved it is they did this. Okay, this is the x-axis, right? This is the y-axis. So they found the angle. We know this is the angle. Like in normal polar, you go from the x-axis, and you go counterclockwise. So they want this angle. This is what we just found, 127. But you can also find it in a different way because we know that this is all 180. We know that this is small fragment is 53. So 127. So you can do both ways, okay. هلا technically يعني it's not wrong to say to find the bearing and then do that. It's not wrong. It's not wrong. Okay, hello, we found the angle. Now they want the Cartesian coordinates. How do we find the I and J? We can just switch it يعني over here and shift recall, and then you put 16.5. The angle 127. Please don't put 323, huh? You get negative 10 or 13.13. Okay, 15. They want us, okay, which vector is directed at west 37 degrees north? So west 37 degrees north أكيد E. شو هالهبل؟ Vector with bearing 37. يعني from north 37. أكيد A. يعني شو هالسؤال الأهبل؟ Whose direction in polar coordinates is 37? يعني you start polar يعني in X and you go up 37. أكيد B. سؤال سخيف والله. Question 16. Okay, so you have vector R1 and R2, and then we want to do R1 minus 4R2. So أكيد it's going to be 15, 2 minus 4, 3 minus 4. So let's distribute. 15, 2. Okay, you can just do minus 4 times this, or you can keep it as minus minus and then 4 times. I'll just distribute minus 4. Okay, let's work mathematically. Minus 4 times 3 is minus 12. Minus 4 times minus 4 is 16. Okay, 15 minus 12, 3. 2 plus 16, 18. So 3i plus 18j. Okay, if they tell you in your, like, if this comes written, if they tell you leave your answer in terms of I and j, you put it as 3i plus 18j. If they tell you leave it in column notation or coordinate notation, then column notation, then you just put it 3, 18. Okay, remember vector symbols, guys. Please, vector symbols, vector arrows. Okay, I should have a vector symbol, j should have a vector symbol, and the letter of the vector should always have a vector symbol. Okay, a vector v is given by 9i plus 40j. It can be expressed as, okay, they just want you to convert it into polar. Okay, let's just convert it polar. 9, 40. Okay, the magnitude is 41 and the angle is 77. If this does come written, guys, أول شيء you need r, right? Polar is always r and theta. You need the magnitude and you need the angle. Magnitude, radical, 9 squared plus 40 squared equals 41. Theta, you do shift tan 40 over 9, shift tan y over x. Okay, in case it comes written. Again, and I doubt, I'm not sure. I still haven't seen what might come written. Okay, vector c equals a plus b. Okay, two ways to add vectors. When you have the head connected to the tail, it's the triangle method. Okay, but if you have tail connected to tail like this, then you use the parallelogram method and you connect. Okay, like this. Here we don't have any head connected to any tail, it's tail with tail, so you use the parallelogram method. This is wrong, this is akid wrong, this is akid wrong. Okay, question 19. Okay, what is the magnitude of r? Just put 8 squared, radical 8 squared plus minus 15 squared, 17. Okay, that's it. Thank you so much for watching. Good luck.